we're just going to talk about now how C# is a strongly typed language. And this can be a pain and it can cause trouble in your programs. Now what I mean by it's strongly typed, in the sense of it won't let you make an integer variable. Sorry, it won't make you store the contents of an integer variable in the contents of a byte variable directly without using some typecasting changing. And I can see why C# is typecast, but it is a pain, especially when you come from a language like Pascal or Delphi, where simply converting from one number type to another was no problem. However, the only problem with that would be if you tried to pass a real into an integer and you didn't pass in a whole number. So typecasting does have its advantages. However, C# is extremely type sensitive. So we're going to look at how we can get across a few of the hurdles that are contained in this. So to do this, I'm now actually going to create a new project, and it's going to be a C# console application. I'm going to call it type demo. Now what we're going to do is, again, in the main, get rid of the string bit for now. We're going to declare some variables. We're going to declare a byte, number 1, an int, number 2, a float, number 3, and a double, number 4. Those are all declared. I'm going to all initialize them with different data. So, and like so. So all those variables have been initialized. They're underlined green, by the way, because we've not used them. And then I'm going to do a console.read line. So that's our basic program. It will run, do absolutely nothing except pause because of our write line. Okay. So we've got number 1, number 2, number 3, and number 4. Now I couldn't do number 1 equals number 2, like so. Oops, number 1 equals number 1. Yeah, that will work fine. No. I couldn't do number 1 equals number 2 like that. And as you can see, it comes up with an error. Cannot implicitly convert type int to byte. An explicit conversion exists, or you're missing a cast. So what we have to do is we have to use one of these. So we're going to do an open parentheses or an open bracket, and we're just going to type in byte, and then we're going to do the close bracket. So what this does is, it is basically a quick way of typecasting. So the number 2 will get converted into a byte, and then the result will get stored in number 1. So now I can run that and it works fine. In fact, I'll just do some writing on the screen. Write line number 1, and then I'll write all of them out there like so. Write line. Silly mistake there, but anyway. And that one, and finally that one. So there we are. We're just writing out all the numbers, and as you can see, that now works, whereas before it doesn't. Again, I'm going to this time do a number 3 and try storing that in the result of number 1, and I can't do that. So this time what we do is do an open bracket, and we're going to convert it again to a byte, like so. And it converts the number 3 into a byte, which we can see number 3 is 84.34. A byte is like an integer in the sense of it has no whole decimal places, so the 0.34 gets chopped off. And then we're going to do number 2 equals, and number 2 is an integer, so we need to do int instead of byte there, and I'm going to set that to number 4, like so. And as you can see, number 4 has been set to 34. It basically gets rid of everything after the decimal place. But let's say we want to round the numbers up instead of just trunksing them like we're doing. Well, there is another way that we can actually typecast, and that's using the convert function. So here I'm going to type in, what we're going to do is I'm just going to do, under number 1, I'm going to write convert.to, and I'm going to convert it to an int 32, that's your standard integer, and I'm going to type in number 4, like so. And then here I'm just going to explain a few things. And now you've noticed this thing, it says it cannot convert from an integer to a byte, because I've just made a mistake on the conversion thing. So what I'm just going to do here for reference purposes is convert that into an integer. I could have put here convert to byte and that would have worked fine, but I just want to show you how convert and int work differently. So under the right line I'm just going to put this using convert dot to int 32, like so, and here using int. And you'll just notice the difference. Using convert to int 32, you see this is all number 4, we get 34.59. It rounds the decimal places, which of course because it's over 0.5 it will get rounded up to 35, and the result is stored there, as you can see. However, using int to convert, it just knocks off everything after the decimal place and afterward, so that's it gets you 34. And that is really the way that you handle typecasting in C#.